Welcome back to Mr. Aparicio's geometry course. Today we are starting Unit 2, which is all about reasoning and logic and proving that things are true in geometry. We're going to start off with section 2.1, which is on conditional statements. Let's get into it. This unit is very unique in geometry and that there's not a lot of math that we're going to be doing here in Unit 2. Instead, we're going to be using a lot of reasoning, logic. We're going to be writing a lot of sentences, evaluating a lot of sentences, and we're starting off with conditional statements. Conditional statement is a logical statement that contains a hypothesis and a conclusion. So the hypothesis of a statement, we're going to associate with the word if and the letter P, and the conclusion of a statement, we're going to associate with the word then and the letter Q. Right? So in symbol form, what this looks like, if the hypothesis is P and the conclusion is Q, well, typically we come up with a hypothesis first, and then if we're talking scientific method, we run some sort of experiment, and then we come up with a conclusion at the end. So the way that we write that with symbols is P for hypothesis, then something happens for us, that would be logical thinking and reasoning, then we come to a conclusion. So that P with an arrow pointing to the Q shows a hypothesis to a conclusion. That's the structure of a conditional statement. In our first example, we were asked to identify the hypothesis and conclusion of a conditional statement. Let's first understand why this is a conditional statement. It's really easy because it has if and then provided. Remember, your hypothesis is typically what goes with if in the statement. So in this, that would be if a shape is a triangle. That would be your hypothesis. Right, your conclusion would then be the thing that follows the then. So then it has three sides, so having three sides would be the conclusion for this figure. Right, so again, your hypothesis in this example would be a shape is a triangle. And your conclusion would be it has three sides. In our next example here, we are asked to find the hypothesis and conclusion of a statement that is not conditional, meaning there is not an if and then involved here. If that's the case, what you can typically do is identify the subject of your statement as the hypothesis. For example, this statement is talking about complementary angles. So we can say that the hypothesis is just that subject. So the hypothesis is just angles that are complementary, okay? Then your conclusion would be like the adjective, the descriptor, the fact for that object. So in this case, it's they have a sum of 90 degrees. So your conclusion would just be have a sum of 90 degrees. So again, if you're not in if-then form, your subject you can think of as your hypothesis, all complementary angles, and then the details about that subject would be your conclusion. Complementary angles have a sum of 90 degrees. In the next example here, we're asked to rewrite this statement in if-then form. And this is where we can literally just take that hypothesis and conclusion and just make it make sense grammatically in a sense. So we obviously wouldn't say if complementary angles. We would say something like if angles are complementary, then they have a sum of 90 degrees. That would be rewriting that statement in if-then form, making it a conditional statement. Now, we don't always want to get caught up in thinking that the hypothesis has to come first. As we see in the next example, that is not always the case. This statement says, you are in Florida if you are in Miami, right? The hypothesis, again, we want to associate with the word if. And so following if here is you are in Miami, that would be the hypothesis of this statement. You are in Miami. And the conclusion then would be you are in Florida. So sometimes the order can be a little tricky here. It may make more sense if you were to read this with that part of the statement coming first. If you are in Miami, then you are in Florida. And that is exactly what we're asked to do down here, to rewrite the statement in if-then form. Typically, we would put the hypothesis first in these statements. So we would say, if you are in Miami, then you are in Florida. Now it's important to learn that there are different types of conditional statements. There are actually three types that we need to learn of, right? One is called the converse. And the converse is just a conditional statement when you exchange, it's supposed to be an E there at the beginning, sorry for my handwriting, when you exchange the hypothesis and conclusion of a conditional statement. So as we learned before, remember that a conditional statement is if P, then Q. If hypothesis, then conclusion. But for the converse of a statement, we just flip those. So we would say, okay, if Q, then P. If conclusion, then hypothesis. That's what a converse is. In our first example, we're asked to write the converse of the following statement. If angles are supplementary, then they have a sum of 180 degrees. And being converse would just ask us to flip the places of the hypothesis and conclusion. Now the word if still remains at the beginning, right? We're not flipping the if and the then. We're just taking the hypothesis and conclusion themselves and exchanging places. So this statement would then become, if angles have a sum of 180 degrees, then they are supplementary. And our next example is again asking us to write the converse of a statement. And we'll see here that when you write the converse of a statement, it doesn't always make sense, meaning the converse is not always true of a conditional statement. So this conditional says, if you live in Volusia County, then you live in Florida, which is absolutely true. But the converse of it is not true. So remember, converse, we're exchanging the hypothesis and conclusion. So if you live in Florida, then you live in Volusia County. Which is not true. You could live in Seminole County or Orange County or Dade County or wherever, right? You don't have to live in Volusia County to live in Florida. And this brings us to an important note here, right? For all the things that we learn of in geometry, all of our postulates, all of our theorems, all of our definitions, they're only true if the conditional and the converse of them are true, right? And this is shown in this example here. If angles are supplementary, then they have a sum of 180 degrees. That's true. The converse of it is also true. If angles have a sum of 180 degrees, then they are supplementary. All things that we learn in geometry follow this. If we write the converse of a conditional statement in geometry, it must be true for all things that we learn in this subject. So remember, we have three types of conditional statements that we're going to be learning about. We just got over the converse statement. And negation is not a type of conditional statement, but it's something we need to understand in order to understand the other two conditional statements. So the negation is the opposite of the original statement. The exact opposite. So if you say something is, to negate it would be to say that it is not. And if you say that you don't do this, then the negation of that would be that you do this, right? So it's always the opposite of a thing. To show that in symbols, what we would put is just a little squiggly line, like that. All right, so if you were told that, hey, this conclusion is true, this Q is true, well, the negation of that would be putting a little squiggly in front of it, like so. In our first little example here, we're asked to negate this statement. So this is not a conditional statement, it's not an if-then form, can't even be put in if-then form, but we can negate it by just saying the opposite of what it says. This says the angles are supplementary. Well, the negation would just be saying the opposite of that, so that would be the angles are not supplementary. And that's typically how negation is going to work throughout this unit. We're going to be adding knots or taking away knots to negate statements. The next conditional statement we need to learn about is the inverse. And the inverse is the negation of both the hypothesis and conclusion of a conditional statement. Okay, so remember, any conditional statement, we say if P, then Q. If this happens, then this happens. If hypothesis, then conclusion. The inverse would be negating both of those. So if P, then Q, if that is your statement, the negation would be if not P, then not Q. In our first example, we're asked to write the inverse of the statement. If two angles are a linear pair, then they are adjacent. Absolutely a true statement. Remember, negation would be saying the opposite of this, but not just for the end. Remember, it happens to both the hypothesis and the conclusion. So the negation of this statement would be if two angles are not a linear pair, then they are not adjacent. For our next example here, go ahead and pause the video and see if you can write the inverse of this conditional statement on your own. Let's see if you remember to negate both the hypothesis and the conclusion. So if you are fishing, the opposite of that would be if you are not fishing. Then the conclusion says, then you are near water. And again, we need to negate that as well. So we would say, then you are not near water. So remember, when we write these conditional statements, we're always including the if and the then, but depending on the type of conditional statements, we'll negate or we'll exchange hypothesis and conclusion. Again, for the inverse, we're just negating. We're not flipping like we did for the converse. We're not exchanging the hypothesis and conclusion. We're just negating both of them by adding nots. I thought this would be important to share. A lot of people will think that when we're writing an inverse statement, that we're going to either have both the hypothesis and conclusion having a not thrown in, or both having a not removed from them. That's not always the case. If you look at this statement, if you are tall, then you are not short. To write the inverse of this, we negate both, which means the not is going to end up being where the hypothesis is instead of the conclusion. For example, to negate if you are tall, we would write if you are not tall. Then for the conclusion, it says then you are not short. Well, we want to negate that as well. And to do that, we would be taking away the not of that one. So we would say then you are short. So to write an inverse doesn't mean you're going to have two nots in your statement or have no nots in your statement. You could have one of each. Remember, the key is that you're writing the opposite of what your hypothesis and conclusion says. Quick recap before we do our last conditional statement. Remember, we have the converse when we just exchange the hypothesis and conclusion. We have the inverse where we negate the hypothesis and conclusion. And our last conditional statement is called the contrapositive. And that is when we have the exchange and the negation of the hypothesis and conclusion of a statement. So remember, your typical conditional statement is if P, then Q. If hypothesis, then conclusion. The contrapositive would be to switch both of them. So if Q, then P, but also to negate them. So if not Q, then not P. In our first example, we're asked to write the contrapositive of the following statement. If two angles share a side and a vertex, then they are adjacent angles, which is absolutely a true statement. We're going to write the contrapositive by flipping the hypothesis and conclusion and negating the hypothesis and conclusion. So that they are adjacent part is going to become the front of our sentence, but we're going to write the opposite of it. So we're going to write that they are not adjacent. So the way this would look grammatically correct, let's say if two angles are not adjacent. So again, that means I flipped my conclusion to the front and I've negated it, said the opposite. Then our hypothesis would switch places in the back. We would say that they do not share a side and a vertex. That's negating this. Then they do not share a side and a vertex. So again, contrapositive, flipping and opposites, flipping and negating. Our next example asks us to write the contrapositive here. Let's see if you can do that on your own. Go ahead and pause the video and see if you can accurately write the contrapositive for this statement. So let's see if you remember to exchange and negate. So to exchange, we'll put this they are congruent part at the front of your sentence, but we need the opposite of that. So the opposite of them being congruent would be them being not congruent. So if two angles are not congruent, then the hypothesis now is coming at the end, and again, we need the opposite of it. So here it said they are vertical, so the opposite would be they are not vertical. So then they are not vertical. We now have a chance to write all of our conditional statements when given a statement to start with. So we have a statement here, perpendicular lines intersect at right angles. This is not something we've officially learned yet in geometry, but it is extremely important. Perpendicular lines do intersect at right angles. We're going to make this a conditional statement by putting it in if-then form. Remember, that's what makes a statement conditional. And then we'll write the converse, inverse, and contrapositive for it. So remember, if-then, if hypothesis, then conclusion. If we're not already in if-then form, and we need to write that conditionally, remember that the subject of your statement can be your hypothesis, that part that follows the if. So for this, the subject of the statement is the perpendicular lines. So I could say, if lines are perpendicular, my hypothesis, then the detail is our conclusion. Well, they intersect at right angles. So I could say, then they intersect at right angles. Now that we have a conditional statement in if-then form, we can come up with our converse, inverse, and contrapositive, right? And so the struggle will be, can you remember which is which? Which one's the exchange? Which one's the negation? Which one's both of those things? So the converse is just the exchange. So we're just flipping what comes after the if and the then, and just making sure that the sentence makes sense after we do that exchange, right? So to exchange, I would say, if angles intersect, not angles, that wouldn't be the right word again, it's gotta make sense. If lines intersect at right angles, then they are perpendicular. Here's again that thing in geometry, when a statement and its converse are both true, it's something that we use in geometry. That is the case here. Remember, the inverse of a statement would be to negate the hypothesis and conclusion. So again, this is our original conditional statement up top. That's one where we're going to negate our hypothesis and conclusion. So the opposite of if lines are perpendicular would be if lines are not perpendicular. Then the opposite of they intersect at right angles would be then they do not intersect at right angles. And then the last statement we're writing is the contrapositive, which is essentially combining both of the converse and inverse. We're going to exchange and we're going to negate. Okay? So the exchange, remember, is flipping what comes after the if and then. So the intersecting at right angles will come first. But for the contrapositive, we're also going to negate that. So we would say, if lines do not intersect at right angles, then, again, our hypothesis is exchanging to the end, and we're going to negate it. So then they are not perpendicular. So yeah, that's converse, inverse, contrapositive, all from our original conditional statement. This brings us to a new term, which is biconditional statements, which is just a statement that contains the phrase if and only if. As an example here to the right, you can vote if and only if you're 18 or older. All right, so it's not if-then form anymore. It's an if and only if thrown in the middle of the statement. This can only happen, as stated here, when a statement and its converse are both true. Like, remember all of our postulates and theorems that we use in geometry. So, as an example here, we are given this statement. If an angle is obtuse, then it's greater than 90 degrees. Absolutely true. Let's see if the converse is true. Remember, the converse would be exchanging the hypothesis and conclusion. Right? So we would say, if an angle is greater than 90 degrees, then it is obtuse. That is also true. So because the original statement and its converse are both true, we can now write a biconditional statement, kind of combining both of these things into an accepted geometry fact, right? We say an angle is obtuse if and only if it's greater than 90 degrees. Here's a chance for you to be creative. You're going to write your own statement, and you're going to write a converse for it, and you're going to make sure that your statement and the converse are both true, and then you're going to write a biconditional statement for it. I'm going to give you an example of something really quick that doesn't work, all right? I'm located in Central Florida. I'm a big fan of the Orlando Magic, so I can make this statement that is true. If you play for the Orlando Magic, then you are a basketball player. Absolutely a true statement. Everyone who plays for the Orlando Magic is a basketball player. However, the converse of that statement is not true. Okay? The converse, remember, the exchange of the hypothesis and conclusion. If you are a basketball player, then you play for the Orlando Magic. That is not true. There's plenty of other professional teams, semi-professional teams, amateur teams, and so on. You don't have to play for the Orlando Magic to be considered a basketball player. So that statement doesn't work. An example of something that could work would just be any definition or fact that you know of from geometry. For example, I know that if angles are complementary, then they have a sum of 90 degrees. The converse of that is also true. If angles have a sum of 90 degrees, then they are complementary angles. That now, because the original statement and the converse are both true, can be written as a biconditional statement, where I can say angles are complementary if and only if they have a sum of 90 degrees. So again, I want you to take the time on your own, pause the video, see if you can come up with your own statement. It doesn't have to be math related, where the converse of your statement is also true, then write it as a biconditional statement. Guys, this wraps up our lesson on conditional statements. I will see you guys in the next video.